What if I told you that a quiet night shift cleaner could solve a server crisis in minutes that had stumped an entire team of engineers for weeks, and that this same person once designed the infrastructure powering millions of Amazon transactions? This is the story of Maya Chen, a 34-year-old former senior software engineer who now pushes a cleaning cart through the halls of Data Vault Technologies, one of Silicon Valley's fastest-growing cloud storage companies. Every evening at 9 p.m. sharp, Maya would badge into the gleaming glass headquarters of Data Vault Technologies in downtown San Jose. Her worn Nike sneakers squeaked softly against the polished concrete floors as she wheeled her cart past rows of empty desks where software engineers had spent another grueling day wrestling with code. The building hummed with the constant whir of servers, processing petabytes of data for clients ranging from small startups to Fortune 500 companies. Maya moved through these spaces like a ghost, invisible to the few late-night workers who occasionally glanced up from their monitors with tired, unfocused eyes. The security guard at the front desk, Roberto Martinez, was one of the few people who acknowledged her presence. "Evening, Maya," he'd say with genuine warmth, his weathered face creasing into a smile. Roberto was a former construction foreman who understood what it meant to work with your hands while others worked with their minds. Maya would nod back, her voice barely above a whisper when she replied, "Good evening, Roberto. How's your grandson doing in his computer class?" These brief exchanges were often the only conversations Maya had during her entire 8-hour shift. Maya's daily routine was methodical and precise. She'd start on the executive floor, the 20th level, where floor-to-ceiling windows offered breathtaking views of the San Francisco Bay. Here, the offices were spacious and pristine, with ergonomic furniture and motivational quotes printed on expensive canvas. The executives who occupied these spaces during the day left behind evidence of their high-stakes decision-making. Whiteboards covered in revenue projections, conference tables scattered with venture capital term sheets, and trash bins filled with discarded protein bar wrappers and empty energy drink cans. From there, Maya would descend through the engineering floors, each level buzzing with a different energy. The senior developers on the 18th floor maintained neat, organized workspaces with multiple monitors displaying complex code architectures. The mid-level programmers on the 17th floor had more cluttered desks, evidence of the intense pressure to deliver features quickly in the competitive tech landscape. The junior developers and interns occupied the 16th floor, their areas chaotic with programming books, sticky notes covering every surface, and the occasional stress ball or fidget spinner. What none of these highly educated, well-compensated professionals knew was that Maya understood their work better than most of them did. As she emptied their trash bins and wiped down their keyboards, she couldn't help but notice the code snippets scrawled on discarded papers, the architecture diagrams left on whiteboards, and the error messages displayed on monitors that developers had abandoned in frustration. Her trained eye automatically analyzed the problems they were trying to solve, often identifying inefficiencies or potential solutions that the original programmers had missed. Maya's journey to this janitorial position was a story of resilience forged through unimaginable loss. Born in Seattle to immigrant parents who had sacrificed everything to give their children opportunities in America, Maya had excelled in mathematics and computer science from an early age. Her father, a former electrical engineer in Taiwan, who drove taxis in Seattle to support his family, would help her with calculus homework at their kitchen table late into the night. Her mother, who had been a teacher in Taiwan but worked as a seamstress in America, instilled in Maya a love of learning and an understanding that education was the pathway to a better life. Maya's academic achievements had been extraordinary. She graduated summa cum laude from the University of Washington with a degree in computer science and a specialization in distributed systems. Her senior thesis on scalable database architectures caught the attention of recruiters from major tech companies, and she received offers from Google, Microsoft, and Amazon. She chose Amazon, drawn by the company's focus on infrastructure and the opportunity to work on systems that would serve millions of customers worldwide. At Amazon Web Services, Maya had thrived. She was part of the team that designed the elastic load balancing systems that kept the company's massive e-commerce platform running during peak traffic periods like Black Friday and Prime Day. Her colleagues respected her ability to think through complex problems systematically, identifying potential failure points before they became critical issues. She had a gift for writing clean, efficient code that other engineers could easily understand and maintain. Within 3 years, she had been promoted to senior software engineer, leading a team of 12 developers working on next-generation cloud storage solutions. Maya's personal life had been equally fulfilling. She had married David Chen, a fellow software engineer she met during a hackathon in San Francisco. Together, they had purchased a modest home in Fremont, dreaming of starting a family and building a life around their shared passion for technology. David specialized in machine learning algorithms, and their evening conversations often centered around the exciting possibilities emerging in artificial intelligence and data analysis. They would spend weekends hiking in the Santa Cruz Mountains, discussing architectural patterns and debating the merits of different programming languages while surrounded by redwood trees and mountain vistas. The trajectory of Maya's life changed irrevocably on a rainy Tuesday evening in November. David had been working late at his startup, a company developing predictive analytics software for healthcare providers. He was driving home through the winding roads of the Santa Cruz Mountains when a drunk driver ran a red light at a rural intersection. The collision was instantaneous and fatal. David was pronounced dead at the scene, and Maya's world collapsed in a single phone call from the California Highway Patrol. The grief that followed was overwhelming and all-consuming. Maya found herself unable to concentrate on complex programming tasks, unable to engage in the collaborative problem-solving that had once energized her. The very code that had been her passion now reminded her of David and the future they would never share. She took bereavement leave from Amazon, expecting to return after a few weeks of mourning. Instead, the weeks turned into months as depression settled over her like a heavy blanket. Amazon's human resources department was initially understanding and supportive, but after 4 months of medical leave, Maya realized she wasn't ready to return to the high-pressure environment of software development. The thought of debugging complex distributed systems or leading team meetings filled her with anxiety that made her hands shake and her breathing shallow. She submitted her resignation letter on a grey February morning, walking away from a 6-figure salary and a career that had once defined her identity. The financial reality of grief hit quickly. Without David's income, and with only modest savings, Maya struggled to maintain the mortgage payments on their Fremont home. She had invested most of her money in technology stocks and retirement accounts that would penalize early withdrawal. The house, filled with memories of their shared dreams, became too painful to inhabit. She sold it at a loss during the real estate downturn and moved into a small studio apartment in San Jose, trying to figure out how to rebuild a life she no longer recognized. Maya's attempts to return to software engineering were unsuccessful. During interviews, she would freeze up when asked about recent projects or current technologies. The rapid pace of change in the tech industry meant that her knowledge was becoming outdated with each passing month. Interviewers would notice the gap in her resume and ask probing questions about her time away from the field. Maya couldn't bring herself to explain about David's death and her ongoing struggle with depression, so she would offer vague explanations about taking time for personal projects. These interviews invariably ended with polite rejections and suggestions that she might want to consider positions at a more junior level. The cleaning job at Data Vault Technologies came through a temp agency that didn't require extensive background checks or technical interviews. Maya was overqualified by any reasonable measure, but she needed steady income and health insurance. The work was solitary and predictable, requiring no complex decision-making or collaborative problem-solving. She could arrive at 9 p.m., complete her assigned tasks, and leave at 5 a.m. without having to navigate office politics or explain her career trajectory to curious colleagues. What Maya hadn't anticipated was how being surrounded by technology would gradually reawaken her dormant passion for engineering. As she cleaned the Data Vault offices night after night, she began to understand the company's technical challenges through the artifacts left behind by the development team. Error logs, printed and abandoned on desks, told stories of system failures and debugging sessions. Whiteboard diagrams revealed architectural decisions and their trade-offs. Overheard conversations between late-night developers painted a picture of a company struggling to scale its infrastructure to meet growing customer demand. Data Vault Technologies had grown rapidly from a startup serving small businesses to a major player competing with Amazon S3 and Google Cloud Storage. The company's original architecture, designed for thousands of users, was buckling under the pressure of serving millions. The engineering team, led by brilliant but overworked developers, was constantly fighting fires rather than implementing long-term solutions. They were adding servers and patches to systems that needed fundamental redesign, creating increasingly complex and fragile infrastructure. Maya recognized the symptoms because she had solved similar problems at Amazon. She could see the bottlenecks in their database queries, the inefficiencies in their load balancing, and the potential failure points in their disaster recovery systems. But she was just the night shift cleaner, invisible to the decision-makers, who could authorize the changes needed to fix these fundamental issues. She continued her work in silence, storing her observations in a mind trained to analyze and optimize complex systems. The irony wasn't lost on Maya that she was cleaning up after engineers who were struggling with problems she could solve in her sleep, but the gap between her current role and her former expertise felt insurmountable. How could someone who emptied trash bins and mopped floors suddenly claim to understand enterprise-level software architecture? How could she explain that the quiet woman who nodded politely to security guards had once designed systems serving millions of users? The professional world didn't have mechanisms for recognizing hidden expertise in people who occupied invisible roles. Maya's daily routine became a meditation on lost potential and unrecognized capability. She would dust the monitors displaying error messages she could fix, empty the trash bins filled with printouts of code she could optimize, and clean the conference rooms where meetings about problems she understood intimately took place without her input. The building around her hummed with the energy of brilliant minds working hard to solve challenges, unaware that one of their most experienced engineers was pushing a cart through their hallways in the darkness of night. The hierarchy at Data Vault Technologies was as visible as the building's glass architecture. On the 20th floor, Chief Executive Officer Marcus Thompson occupied a corner office with panoramic views of Silicon Valley. At 42, Marcus had built his reputation as a visionary leader who could transform promising startups into market-dominating enterprises. His previous company, a mobile analytics firm, had been acquired by Facebook for $800 million, establishing him as one of the tech industry's most sought-after executives. Marcus dressed in the uniform of Silicon Valley success, perfectly fitted jeans, designer sneakers, and casual button-down shirts that cost more than Maya's monthly rent. Marcus had joined Data Vault 18 months earlier when the company was struggling to compete with established cloud storage giants. His mandate from the board of directors was simple but daunting: scale the company to handle enterprise-level clients while maintaining the agility and innovation that had made them successful with smaller customers. He brought with him a reputation for data-driven decision-making and an ability to inspire engineering teams to push beyond what they thought possible. But Marcus also carried the weight of recent personal tragedy that had fundamentally changed his perspective on leadership and human potential. 6 months before joining DataVault, his younger brother James had taken his own life after struggling with depression and addiction. James had been a brilliant software engineer who had worked at several prestigious tech companies, but his battle with mental health had gradually eroded his confidence and career prospects. In his final months, James had been working a series of temporary jobs, feeling invisible and worthless, despite his technical expertise. The loss of his brother had awakened Marcus to the reality that talented people sometimes found themselves in situations that didn't reflect their capabilities. He had started noticing the support staff in ways he never had before. The security guards who worked multiple jobs to support their families, the custodial workers who kept the offices running, the food service employees who ensured his team stayed fed during long development cycles. These observations had planted seeds of awareness about hidden potential and overlooked contributions, though he hadn't yet learned how to act on these insights in meaningful ways. Marcus's leadership style reflected both his business acumen and his growing sensitivity to human complexity. He held all-hands meetings where he emphasized the company's mission to democratize data storage, making enterprise-level capabilities accessible to organizations of all sizes. He instituted open office hours where any employee could schedule time to discuss ideas or concerns directly with him. These sessions were typically filled with senior engineers and product managers, but Marcus had begun to wonder whether other voices might offer valuable perspectives he wasn't hearing. The technical leadership at DataVault was anchored by Chief Technology Officer Sarah Kim, a 38-year-old former Google engineer who had spent a decade building large-scale distributed systems. Sarah was known throughout Silicon Valley for her ability to architect solutions that could handle massive traffic spikes while maintaining millisecond response times. She had been recruited to DataVault with the specific mandate of rebuilding their infrastructure to support enterprise clients who demanded reliability levels approaching 99.9999% uptime. Sarah's office on the 19th floor was a study in organized chaos. Multiple whiteboards covered the walls, filled with architectural diagrams that mapped the flow of data through DataVault's systems. Her desk held 3 monitors displaying real-time system metrics, code repositories, and performance dashboards that tracked everything from server response times to customer satisfaction scores. She typically arrived at the office by 6 a.m. and rarely left before 10 p.m., driven by an obsessive commitment to technical excellence that had made her one of the most respected CTOs in the industry. But Sarah was also struggling with challenges that kept her awake at night. DataVault's rapid growth had created technical debt that threatened to undermine everything they were trying to accomplish. The company's original architecture, designed by brilliant but inexperienced founders, had been optimized for quick development, rather than long-term scalability. Now, as they tried to serve enterprise clients with millions of users, the system was showing signs of strain that Sarah recognized as potential catastrophic failure points. Every week brought new crises that required immediate attention. Database queries that had worked fine with thousands of users were timing out when serving millions. Load balancers that had handled moderate traffic were failing during peak usage periods. Storage systems designed for small files were struggling. with the large data sets that enterprise clients needed to manage. Sarah's team was excellent at putting out fires, but they were running out of time to implement the fundamental changes needed for long-term stability. The engineering culture at DataVault reflected the company's startup origins and rapid growth trajectory. The development team was young, talented, and incredibly hardworking, but they lacked the experience of building systems at the scale DataVault was trying to achieve. Most of the senior engineers were in their late 20s or early 30s, brilliant individuals who could write elegant code and solve complex problems, but who had never dealt with the infrastructure challenges that came with serving millions of concurrent users. Alex Rodriguez, the lead back-end engineer, exemplified both the strengths and limitations of the team. At 29, Alex had graduated from Stanford with a computer science degree and had spent 4 years at a successful startup that was acquired by Microsoft. He was incredibly skilled at writing efficient algorithms and had an intuitive understanding of how to optimize database performance. But his experience was primarily with systems that served hundreds of thousands of users, not the millions that DataVault was trying to support. Alex worked on the 17th floor with a team of 8 developers who handled the core infrastructure that powered DataVault storage services. Their workspace was a testament to the intensity of their work. Monitors displaying cascading lines of code, whiteboards covered with system architecture diagrams, and desks littered with energy drinks and takeout containers from the late night debugging sessions that had become routine. The team took pride in their ability to ship new features quickly and fix problems as they arose, but they were increasingly overwhelmed by the complexity of the systems they were trying to maintain. The cultural divide between engineering and operations at DataVault was typical of rapidly growing tech companies. The developers who wrote the code were treated as the creative heroes of the organization, recognized for their ability to build new features and solve complex algorithmic problems. The operations team that kept the systems running was viewed as support staff, important but secondary to the core work of innovation. This hierarchy created blind spots where operational insights that could prevent problems were often overlooked, in favor of engineering solutions that addressed symptoms rather than root causes. Maya observed these dynamics from her unique position as someone who understood both the technical challenges and the human systems that created them. During her cleaning rounds, she would overhear conversations between developers who were frustrated by recurring issues they couldn't fully diagnose. She would see printouts of error logs that revealed patterns the engineering team hadn't recognized. She would watch as talented individuals worked incredibly hard to solve problems that could be prevented with different architectural approaches. The most telling example of DataVault's cultural blind spots was evident in how they handled system monitoring and alerting. The engineering team had implemented sophisticated tools that tracked thousands of metrics and generated alerts when various thresholds were exceeded. But these systems produced so much noise that the really important signals often got lost in the constant stream of notifications. Maya could see from the error logs and printed alerts that the team was spending most of their time responding to false positives while missing the subtle indicators that predicted serious problems. Even more concerning was how the company handled knowledge transfer and institutional memory. DataVault had grown so quickly that many of the original developers who understood the foundational architecture had moved on to other companies or been promoted to management roles. The current team was incredibly smart, but they were essentially reverse engineering systems built by people who were no longer available to explain the design decisions and trade-offs that had shaped the current infrastructure. Maya recognized this pattern because she had seen it at Amazon during periods of rapid expansion. The difference was that Amazon had established processes for documenting architectural decisions and mentoring junior engineers. They had senior staff engineers whose job was specifically to maintain institutional knowledge and guide technical direction. DataVault, despite its talent and ambition, was essentially flying blind, making decisions based on incomplete information about their own systems. The pressure on the engineering team was intensified by DataVault's competitive position in the cloud storage market. Amazon Web Services, Google Cloud, and Microsoft Azure had virtually unlimited resources to invest in infrastructure and could absorb temporary performance issues without losing enterprise clients. DataVault, as a smaller player, had to deliver exceptional performance consistently to maintain their market position. A single major outage or performance degradation could result in losing clients who represented millions of dollars in annual revenue. This competitive pressure created a culture where short-term fixes were often prioritized over long-term architectural improvements. The engineering team would implement patches and workarounds that kept systems running in the immediate term, but these solutions often added complexity that made future problems more difficult to diagnose and resolve. Maya could see this pattern in the increasingly convoluted monitoring scripts and the growing number of special case handling routines that had been added to manage edge cases and unexpected interactions. The irony that wasn't lost on Maya was that DataVault's leadership genuinely cared about creating an inclusive and supportive workplace culture. Marcus regularly spoke about the importance of diverse perspectives and psychological safety. Sarah had implemented mentoring programs and encouraged junior engineers to propose innovative solutions. The company offered generous benefits, flexible working arrangements, and professional development opportunities that exceeded industry standards. But these cultural initiatives were primarily focused on the engineering and business development teams. The support staff who kept the company running, security guards, custodial workers, food service employees, and administrative assistants, were employed through third-party contractors and largely invisible to the initiatives designed to foster innovation and collaboration. Maya existed in this shadow economy of workers who were essential to the company's daily operations, but excluded from the intellectual community that drove technical decision-making. The physical layout of the DataVault building reinforced these hierarchical divisions. The executive floors featured open-plan workspaces designed to encourage collaboration, with comfortable seating areas, high-end coffee machines, and walls covered with inspirational quotes about innovation and teamwork. The engineering floors were equipped with the latest technology, multiple monitors, ergonomic furniture, and quiet spaces for focused work. Maya's world was fundamentally different. The custodial supply closets were cramped and poorly ventilated, located in basement areas or hidden corners of each floor. She had no desk, no computer access, and no official means of communicating with the technical staff beyond brief interactions when their paths crossed during late-night work sessions. Her uniform, khaki pants and a blue polo shirt with the cleaning company's logo, marked her as part of the invisible workforce that kept the building functioning but wasn't considered part of the intellectual community that defined DataVault's identity. What Maya's colleagues couldn't see beneath her quiet demeanor and cleaning uniform was a mind that had architected some of the most sophisticated distributed systems in the technology industry. While she methodically emptied trash bins and sanitized workstations, her brain automatically processed the technical fragments scattered across DataVault's offices with the analytical precision that had once made her one of Amazon's most valued infrastructure engineers. During her nightly rounds, Maya encountered a treasure trove of technical information that painted a detailed picture of DataVault's architectural challenges. Crumpled printouts in wastebaskets contained stack traces from system failures that revealed memory leaks in critical services. Abandoned sticky notes on monitors displayed database query optimization attempts that were heading in the wrong direction. Whiteboard diagrams left from engineering meetings showed load balancing strategies that Maya immediately recognized as scalability bottlenecks waiting to happen. The depth of Maya's technical expertise became apparent in how she interpreted these scattered clues. When she saw error logs indicating cascading timeouts in Data Vault's microservices architecture, she didn't just recognize the symptoms. She understood the root cause. The system was experiencing what distributed systems engineers called thundering herd problems, where multiple services would simultaneously retry failed requests, creating exponential load that overwhelmed downstream systems. Maya had solved this exact issue at Amazon using circuit breaker patterns and exponential back-off algorithms. Maya's knowledge extended far beyond theoretical understanding. She had hands-on experience designing systems that handled traffic spikes during Amazon's biggest sales events. She understood how to implement graceful degradation strategies that maintained core functionality even when individual components failed. She knew the subtle differences between various load-balancing algorithms and could predict how each would perform under different traffic patterns. Most importantly, she had developed an intuitive understanding of how human behavior interacted with technical systems, knowledge that was crucial for building infrastructure that worked reliably in real-world conditions. The evidence of Data Vault's technical struggles was everywhere Maya looked. In Alex Rodriguez's workspace, she found printed emails from enterprise clients complaining about intermittent service outages during peak usage periods. The timestamps on these complaints revealed a pattern that Maya recognized immediately. The failures were occurring when legitimate traffic spikes coincided with automated backup processes, creating resource contention that the current architecture couldn't handle gracefully. Maya had encountered similar issues during her time working on Amazon's elastic computing infrastructure. The solution wasn't simply adding more servers, it required redesigning the job scheduling algorithms to distribute background processes across multiple time windows and implementing priority queuing systems that could temporarily defer non-critical operations during high-traffic periods. These were complex architectural changes that required deep understanding of both the technical systems and the business requirements they served. In Sarah Kim's office area, Maya discovered architectural diagrams that revealed Data Vault was using a database sharding strategy that would soon reach its scalability limits. The current approach distributed data based on user account identifiers, which worked well when customers had similar usage patterns. But Maya could see from the performance metrics scattered across various desks that some enterprise clients were generating dramatically more traffic than others, creating hot shards that would eventually overwhelm individual database servers. This was a problem Maya had helped solve at Amazon when they were scaling their product catalog system. The solution involved implementing consistent hashing algorithms that could dynamically redistribute data based on actual usage patterns rather than simple identifier-based distribution. But implementing such changes required careful planning and extensive testing to avoid data loss or service disruptions. Maya knew the technical approaches, but she also understood the operational complexities of migrating live systems serving millions of users. Maya's expertise wasn't limited to back-end infrastructure. During her cleaning rounds through the front-end development areas, she noticed user interface mock-ups and usability testing reports that revealed Data Vault was struggling with client-side performance issues. Large file uploads were failing because the web application didn't implement proper chunking and resume capabilities. Users were experiencing timeout errors during extended operations because the interface didn't provide adequate feedback about long-running processes. These weren't just technical problems, they were user experience issues that could significantly impact customer satisfaction and retention. Maya had worked on similar challenges at Amazon, where they discovered that even small improvements in upload reliability could dramatically reduce customer support costs and increase user engagement. She knew how to implement progressive upload strategies, background processing queues, and real-time status updates that would make DataVault's interface much more robust and user-friendly. Perhaps most importantly, Maya understood the interconnected nature of these various technical challenges. While DataVault's engineering team was treating each problem as a separate issue to be solved independently, Maya could see how they were all symptoms of fundamental architectural decisions that needed to be addressed holistically. The database performance issues were related to the load balancing problems, which were connected to the front-end timeout errors, which were exacerbated by the background job scheduling conflicts. Maya's approach to system design had always been influenced by her understanding of failure modes and cascading effects. At Amazon, she had learned that truly scalable systems needed to be designed with the assumption that individual components would fail regularly. This meant implementing comprehensive monitoring, automated failover mechanisms, and graceful degradation strategies that could maintain service availability even during partial system failures. DataVault's current architecture showed signs of being designed by engineers who hadn't yet experienced large-scale system failures. The monitoring systems generated alerts for individual component problems, but didn't track the system-level metrics that could predict cascading failures. The error handling was optimized for development convenience rather than operational reliability. The deployment processes didn't include sufficient rollback mechanisms or canary testing to safely introduce changes to production systems. What made Maya's hidden expertise particularly valuable was her deep understanding of the operational aspects of running large-scale distributed systems. Many brilliant engineers could design elegant architectures on whiteboards, but Maya had experience with the mundane but critical details that determined whether systems actually worked reliably in production environments. She understood how to configure database connection pooling to prevent resource exhaustion. She knew how to implement effective caching strategies that could handle cache invalidation gracefully. She had experience with the monitoring and alerting configurations that could distinguish between normal operational noise and genuine problems requiring immediate attention. Maya's knowledge extended to the business implications of various technical decisions. She understood how different architectural choices would affect DataVault's ability to compete with larger cloud providers. She could predict which approaches would scale cost-effectively as the company grew and which would require expensive infrastructure investments that could threaten profitability. Her experience at Amazon had taught her how to balance technical elegance with practical constraints like development timelines, operational complexity, and budget limitations. During her quiet hours in the building, Maya found herself mentally redesigning DataVault's architecture to address the fundamental scalability challenges she observed. She would imagine how to implement distributed caching layers that could reduce database load while maintaining data consistency. She would think through strategies for migrating from monolithic services to properly designed microservices without disrupting existing functionality. She would consider how to implement the monitoring and observability tools that would give the engineering team better visibility into system behavior and performance trends. Maya's architectural thinking was shaped by her understanding that the best systems were designed to be operated by teams of normal humans rather than heroic individual contributors. She had seen too many startups create systems that only worked when specific engineers were available to troubleshoot problems or manually manage complex deployment processes. Sustainable architecture required automation, clear documentation, and designs that could be understood and maintained by multiple team members. The tragedy of Maya's situation was that her expertise was not only unrecognized, but actively invisible to the people who could benefit from it most. When she cleaned the conference rooms where architecture decisions were debated, she couldn't participate in discussions where her insights could prevent months of costly mistakes. When she organized papers containing performance metrics that revealed systemic problems, she had no mechanism for communicating the patterns she recognized to the engineers who could act on them. Maya had developed several informal strategies for trying to share her observations without overstepping professional boundaries. She would occasionally arrange discarded printouts in ways that highlighted important information, hoping that engineers might notice patterns they had previously missed. She would clean whiteboards carefully, preserving diagrams that seemed particularly important while erasing outdated information that might be causing confusion. These subtle interventions were her only way of trying to contribute to the technical discussions happening around her. The most frustrating aspect of Maya's situation was watching the Data Vault team struggle with problems that had well-known solutions in the broader infrastructure engineering community. The challenges they were facing weren't unique or unprecedented. They were common growing pains that many successful companies had navigated with proper technical guidance. Maya knew the relevant research papers, open-source tools, and architectural patterns that could address their specific issues, but she had no credible way to introduce this information into their decision-making processes. Maya's technical knowledge wasn't just theoretical, it was grounded in practical experience with the specific technologies that Data Vault was using. She was familiar with the database systems, programming languages, and cloud infrastructure platforms that formed the foundation of their architecture. She understood the configuration options, performance tuning parameters, and operational best practices that could significantly improve system reliability and efficiency. More importantly, she had experience with the migration strategies and testing approaches that could allow Data Vault to implement improvements without risking service disruptions. The depth of Maya's expertise extended to emerging technologies and industry trends that could position Data Vault for future growth. She followed developments in container orchestration, serverless computing, and edge computing technologies that could provide competitive advantages if implemented thoughtfully. She understood how artificial intelligence and machine learning could be applied to infrastructure monitoring and automated scaling decisions. Her perspective combined deep technical knowledge with strategic thinking about how technology choices would affect business outcomes. Alex Rodriguez and his back-end engineering team found themselves trapped in a reactive cycle that prevented them from implementing the fundamental changes needed for long-term stability. Every day brought new production issues that required immediate attention, leaving no time for the careful planning and methodical implementation that major architectural changes required. The team was essentially performing surgery on a patient who was bleeding in multiple places simultaneously, unable to step back and address the underlying conditions causing the hemorrhaging. The technical crisis was exacerbated by Data Vault's competitive position in an increasingly crowded cloud storage market. Amazon Web Services had announced new enterprise features that directly addressed some of Data Vault's key differentiators. Google Cloud was aggressively pursuing enterprise clients with pricing strategies that Data Vault couldn't match without sacrificing profitability. Microsoft Azure was leveraging its existing enterprise relationships to offer integrated solutions that positioned Data Vault as an unnecessary third-party dependency. Maya observed these competitive pressures through the strategic documents and market analysis reports that accumulated in executive conference rooms. DataVault's market research showed that enterprise clients were increasingly willing to pay premium prices for cloud storage solutions that offered guaranteed reliability and seamless integration with existing enterprise software systems. The company's value proposition had shifted from being a cost-effective alternative to established providers to being a specialized solution that could deliver superior performance for specific use cases. But delivering on these promises required technical capabilities that DataVault's current architecture couldn't support reliably. The system monitoring tools revealed performance metrics that fluctuated unpredictably based on traffic patterns that the engineering team couldn't fully understand or predict. Database query response times varied by orders of magnitude depending on data distribution patterns that changed as new enterprise clients onboarded their existing datasets. Load balancing effectiveness degraded as client usage profiles became more diverse and specialized. The human cost of this technical crisis became apparent in the increasingly strained atmosphere throughout DataVault's offices. Engineers who had joined the company excited about building cutting-edge technology found themselves spending most of their time firefighting and implementing emergency fixes. The collaborative, innovative culture that had attracted top talent was being replaced by a high-stress environment where individual team members felt personally responsible for system failures that were actually symptoms of architectural limitations. Maya watched this transformation during her nightly rounds, observing the physical evidence of mounting stress in the engineering workspaces. Desks that had once been organized and personalized were now cluttered with energy drinks, prescription medication bottles, and printouts from late-night debugging sessions. Whiteboards that had displayed innovative architectural concepts were covered with incident response procedures and escalation contact lists. The creative energy that had once characterized DataVault's engineering culture was being consumed by the grinding demands of keeping failing systems operational. The customer support organization was experiencing even more direct pressure as enterprise clients demanded explanations and solutions for problems that the technical team couldn't fully diagnose or predict. Support tickets were escalating to engineering teams who were already overwhelmed with production issues, creating a feedback loop where customer-facing problems consumed development resources that were needed for implementing fundamental fixes. The customer success team found themselves making promises about future improvements without clear technical roadmaps for delivering on those commitments. Enterprise clients began implementing their own workarounds and contingency plans that reduced their dependence on DataVault's infrastructure. Morrison Financial started maintaining parallel backup systems with alternative cloud providers, effectively treating DataVault as a secondary rather than primary storage solution. TechFlow Manufacturing implemented additional data replication strategies that reduced their exposure to DataVault's reliability issues, but also reduced their usage of DataVault's premium features that commanded higher pricing. These defensive measures by enterprise clients threatened DataVault's revenue model and growth trajectory in fundamental ways. The company's business plan depended on expanding usage by existing clients as their data storage needs grew over time. But clients who implemented defensive diversification strategies were actually reducing their dependence on DataVault services, limiting future revenue growth potential even if immediate technical problems were resolved. Maya understood these business implications because she had observed similar situations during her time at Amazon Web Services. She knew that enterprise clients who lost confidence in a cloud provider's reliability rarely returned to full dependence, even after technical problems were resolved. The trust required for enterprise relationships was difficult to rebuild once it had been damaged by operational failures that affected critical business processes. The crisis deepened when Data Vault experienced its first major outage during Maya's third month of employment. The failure occurred on a Thursday evening when several enterprise clients were running scheduled data processing jobs that supported their end-of-month reporting cycles. A cascading failure in the database cluster caused widespread service unavailability that lasted for nearly 6 hours, affecting over 70% of Data Vault's enterprise customers during critical business operations. Maya was working her regular shift when the outage began, witnessing the emergency response from her unique perspective as someone who understood both the technical and operational aspects of managing large-scale infrastructure failures. The engineering team's response revealed both their dedication and their limitations in dealing with systemic problems that required coordinated troubleshooting across multiple complex systems. The incident response process followed procedures that Maya recognized as inadequate for the scale and complexity of the technical failure they were experiencing. Individual engineers focused on their specific areas of expertise without sufficient coordination to understand how various system components were interacting during the failure scenario. The monitoring tools generated thousands of alerts that overwhelmed the team's ability to distinguish between symptoms and root causes. Emergency communication with affected clients was delayed because the technical team couldn't provide accurate estimates for restoration times. Maya watched the crisis unfold from the periphery, observing engineers who worked through the night, implementing fixes that addressed individual component failures without resolving the underlying architectural problems that had enabled the cascading failure. She could see from the system diagrams and incident response documentation that the team was treating the outage as a series of independent technical problems rather than a systemic failure that revealed fundamental limitations in their distributed systems design. The aftermath of the outage created a company-wide reckoning about Data Vault's technical direction and competitive viability. Several enterprise clients initiated formal contract reviews that could result in service terminations if satisfactory remediation plans weren't implemented quickly. Investor confidence was shaken by the public visibility of the outage, which had been covered in technology industry publications as an example of the risks associated with relying on smaller cloud providers for mission-critical applications. Marcus Thompson found himself facing the most serious leadership challenge of his tenure at Data Vault. The board of directors demanded comprehensive explanations for the technical failures and detailed plans for preventing similar incidents in the future. Investors who had supported aggressive growth strategies were now questioning whether Data Vault had the technical foundation necessary to compete effectively against established cloud infrastructure providers. Preparing and narrating this type of story took us long efforts and hard work. So if you are enjoying the story, please consider subscribing to our channel. The pressure on Sarah Kim and her engineering organization intensified dramatically as the company struggled to develop credible responses to these stakeholder concerns. Emergency consulting engagements were initiated with external technical experts who could provide independent assessments of Data Vault's infrastructure and recommendations for addressing fundamental architectural limitations. These assessments would ultimately determine whether Data Vault could continue pursuing enterprise clients or would need to refocus on smaller market segments with less demanding reliability requirements. Maya observed these developments with a growing sense of urgency about the gap between Data Vault's technical challenges and the solutions being pursued by the engineering team. She could see that the external consultants were likely to recommend costly infrastructure overhauls that would take months to implement, while customers continued experiencing reliability issues. But she also knew that many of DataVault's most critical problems could be addressed through targeted architectural changes that leveraged her experience with similar systems at Amazon Web Services. The tragedy of the situation was that DataVault possessed the human resources necessary to address their technical challenges, but organizational barriers prevented the most relevant expertise from contributing to the solution. Maya's knowledge of distributed systems architecture and large-scale infrastructure management was exactly what the company needed, but her position as a night shift custodian made it impossible for her insights to reach the decision-makers who could authorize and implement the necessary changes. The breaking point arrived on a frigid Tuesday evening in February, when DataVault faced what would either be their salvation or their complete destruction. Maya was beginning her regular cleaning routine on the 18th floor when she noticed an unusual level of activity in the normally quiet executive conference room. Through the glass walls, she could see Marcus Thompson, Sarah Kim, and the entire senior leadership team gathered around laptops displaying system monitoring dashboards that painted an increasingly dire picture of DataVault's infrastructure stability. The crisis had been building for weeks, but tonight represented the convergence of multiple catastrophic failures that threatened to destroy the company's reputation permanently. 3 of DataVault's largest enterprise clients, Morrison Financial, TechFlow Manufacturing, and Meridian Healthcare, had scheduled critical data migrations that would stress the system beyond anything it had previously handled. These weren't routine operations, but massive data transfers that represented years of accumulated business intelligence being moved to DataVault's platform as part of expanded enterprise contracts worth over $15 million annually. Morrison Financial was migrating 7 years of trading data and risk assessment models that needed to be accessible for regulatory audits scheduled to begin the following Monday. Any delays or data corruption could result in compliance violations that would cost the company millions in penalties and potentially trigger federal investigations. TechFlow Manufacturing was transferring product development archives containing proprietary designs and intellectual property worth hundreds of millions of dollars. Meridian Healthcare was moving patient records and clinical trial data that was essential for ongoing FDA approval processes for new pharmaceutical products. The technical complexity of these simultaneous migrations had pushed DataVault's engineering team beyond their operational limits. Alex Rodriguez and his back-end developers had spent the previous week implementing custom data transfer protocols and monitoring systems designed specifically for these high-stakes operations. Sarah Kim had personally reviewed every aspect of the migration architecture, but the scale and complexity exceeded anything DataVault had previously attempted. The system would be handling data volumes that were 5 times larger than their previous peak usage periods. Maya observed the preparation efforts during her nightly cleaning rounds, noticing the increasing tension and exhaustion among the engineering staff. Whiteboards throughout the development floors were covered with migration timelines, data flow diagrams, and contingency procedures that revealed both the scope of the challenge and the team's recognition that they were operating at the edge of their technical capabilities. Coffee cups and energy drink cans accumulated on desks as engineers worked through multiple consecutive nights, preparing for the coordinated migrations. The first signs of trouble appeared at approximately 8:30 p.m. when Morrison Financial's initial data transfer began experiencing intermittent connectivity issues. The symptoms were subtle initially, slightly elevated response times and occasional retry operations that were within normal parameters for large-scale data transfers. But Maya, who was cleaning workstations near the monitoring displays, immediately recognized the patterns from her experience managing similar operations at Amazon Web Services. The early indicators suggested that the database connection pooling was approaching saturation limits that would create cascading failures once the other clients began their migrations. By 9:15 p.m., when TechFlow Manufacturing initiated their transfer process, the system was exhibiting clear signs of resource contention that the monitoring tools weren't designed to detect effectively. Database query response times were increasing exponentially as the connection pool became overwhelmed by concurrent large-scale operations. The load balancing algorithms were failing to distribute traffic effectively because they hadn't been configured to handle the specialized requirements of massive data migration operations. Maya watched the crisis develop from her unique position as someone who understood both the technical symptoms and their inevitable progression towards system-wide failure. She could see from the error logs and monitoring displays that the engineering team was focused on individual component problems rather than recognizing the systemic nature of the developing crisis. They were implementing targeted fixes for specific symptoms, while the underlying resource exhaustion continued to intensify with each additional data transfer operation. The situation became critical at 10:45 p.m. when Meridian Healthcare attempted to begin their patient data migration simultaneously with the ongoing operations from the other two enterprise clients. The combined load immediately overwhelmed DataVault's database cluster, triggering a cascade of timeout errors and connection failures that affected not only the migration operations, but also the normal business operations of dozens of other clients who relied on DataVault for their daily data storage needs. The engineering team's response followed their established incident response procedures. But these protocols had been designed for isolated component failures rather than the systemic overload they were now experiencing. Individual engineers focused on their specific areas of expertise: database optimization, network connectivity, application server performance, without sufficient coordination to understand how their efforts were interacting with the broader system failure. The monitoring tools generated thousands of alerts that overwhelmed their ability to distinguish between primary causes and secondary effects. Marcus Thompson found himself in the impossible position of trying to manage external communications with three major enterprise clients, while his technical team struggled to understand the scope and root cause of the system failures. The client's technical teams were demanding real-time updates and estimated resolution times that DataVault couldn't provide with confidence. Morrison Financial's compliance officer was already exploring legal options for potential damages if their migration couldn't be completed before the Monday regulatory deadline. Sarah Kim was coordinating the technical response from the main conference room, but the complexity of the distributed systems failure exceeded her team's diagnostic capabilities. The database administrators reported that individual servers were functioning normally, but the cluster as a whole was failing to handle distributed query loads effectively. The network engineers confirmed that bandwidth utilization was within acceptable limits, but packet loss was increasing due to buffer overflows in the load balancing infrastructure. The application developers verified that their code was executing without errors, but response times were degrading due to resource contention at the database layer. Maya observed this coordinated troubleshooting effort during her cleaning rounds, recognizing the fundamental misunderstanding that was preventing the team from implementing effective solutions. The engineers were treating the crisis as a hardware capacity problem that could be resolved by adding more servers or optimizing individual components. But Maya understood that they were actually experiencing a distributed systems coordination failure that required architectural changes to the way multiple large-scale operations were scheduled and managed. The house in Fremont once a symbol of their shared dreams, became a financial burden Maya couldn't sustain. Every room contained memories that made daily life painful. David's desk in the home office where he had worked on his final machine. Learning model. The kitchen where they had cooked together while discussing technical problems. The living room where they had sketched system architectures on the walls. Maya listed the house for sale during a downturn in the Bay Area real estate market, ultimately accepting an offer that was $30,000 less than their purchase price. Moving into a studio apartment in San Jose represented more than just downsizing. It was Maya's attempt to create a living space that didn't constantly remind her of the life she had lost. The apartment was functional but impersonal, furnished with basic items from discount retailers rather than the carefully chosen pieces she and David had selected together. She kept only essential possessions, donating most of their shared belongings. To avoid the emotional weight of constant reminders, Maya's attempts to return to software engineering were repeatedly unsuccessful, creating a cycle of rejection and declining confidence that made each subsequent interview more difficult. Her resume showed an impressive track record at Amazon, but the 4-month gap raised questions that she struggled to answer convincingly. During technical interviews, she would freeze when asked about recent projects or current industry trends. The rapid pace of technological change meant that her knowledge was becoming outdated with each passing month away from active development work. Recruiters and hiring managers would notice the gap in her employment history and ask direct questions about her reasons for leaving Amazon. Maya couldn't bring herself to explain about David's death and her ongoing struggles with depression, so she would offer vague explanations about taking time for personal projects or exploring entrepreneurial opportunities. These explanations were obviously insufficient for senior engineering positions, leading to polite rejections and suggestions that she might want to consider more junior roles. The few companies that offered her junior positions presented their own challenges. Maya's previous experience, commanding 6-figure salaries and leading technical teams, made it difficult to accept roles that paid less than half her former income and offered little intellectual challenge. More problematically, working at a reduced level felt like a betrayal of everything she and David had accomplished together. The career regression seemed to diminish not just her own achievements, but also the significance of their shared professional aspirations. Maya's search for employment became increasingly desperate as her savings dwindled and the life insurance settlement remained tied up in legal proceedings. She applied for positions at smaller companies, startups, and consulting firms, but her interview performance continued to deteriorate as depression and anxiety made it difficult to demonstrate her technical capabilities convincingly. The competitive nature of Silicon Valley's job market meant that any sign of uncertainty or lack of confidence immediately eliminated candidates from consideration. The cleaning position at Data Vault Technologies came through Kelly Services, a temporary employment agency that specialized in placing workers in non-technical roles that didn't require extensive background checks or technical interviews. Maya was clearly overqualified for custodial work, but the agency representative didn't. As probing questions about her career transition, the job offered immediate employment, basic health insurance, and a work schedule that would allow her to avoid the collaborative aspects of engineering work that had become emotionally difficult. Maya's first night at Data Vault was profoundly disorienting. Walking through offices filled with the latest technology, surrounded by the artifacts of high-level technical work, she felt like she was observing her former life from the outside. The whiteboards covered with architectural diagrams reminded her of similar discussions she had led at Amazon. The printouts of performance metrics scattered across desks contained the kind of data she had once analyzed to make critical infrastructure decisions. But now she was there to empty trash bins and clean workstations, rather than contribute to the technical discussions that shaped these systems. The transition from software engineer to night shift cleaner represented more than just a career change. It was a fundamental alteration of Maya's identity and place in the world. She had spent her adult life as a respected technical expert whose opinions influenced systems serving millions of users. Now she was invisible, moving through the same technological environment, but excluded from the intellectual community that gave these spaces their meaning and purpose. The storm clouds gathering over Data Vault Technologies began as whispers in late-night engineering meetings and escalated into company-wide crisis within a matter of weeks. The first signs of trouble appeared in the customer support ticket system, where complaints about service reliability started trending upward during the early months of Maya's employment. Initially, these issues seemed manageable, isolated incidents affecting individual clients during peak usage periods. But the patterns that Maya observed during her nightly cleaning rounds told a different story about systemic problems that were growing more severe with each passing day. Enterprise. Clients were beginning to voice concerns that went beyond typical growing pains. Morrison Financial, Data Vault's largest client with over 2 million users, reported intermittent failures during their quarterly reporting cycles when massive data sets needed to be processed simultaneously. The failures weren't catastrophic outages, but rather performance degradations that caused critical business processes to miss their scheduled completion times. For a financial services company operating under strict regulatory deadlines, these delays represented potential compliance violations that could result in millions of dollars in penalties. TechFlow Manufacturing, another major enterprise client, experienced more dramatic failures during their product development cycles. Their engineering teams relied on Data Vault to store and share large CAD files and simulation data across global development centers. When the storage system failed during critical design reviews, entire product development timelines were jeopardized. The company's CTO, Patricia Williams, sent increasingly urgent emails demanding explanations and remediation plans that Data Vault's customer success team struggled to provide with confidence. Maya witnessed the mounting pressure firsthand as she cleaned the executive floors during increasingly frequent emergency meetings. The conference rooms that had once hosted strategic planning sessions were now occupied by crisis management discussions that stretched deep into the night. She would find whiteboards covered with incident timelines, root cause analysis diagrams, and action item lists that revealed the growing scope of Data Vault's technical challenges. Marcus Thompson's leadership style evolved dramatically as the company faced these mounting pressures. The confident, visionary CEO, who had inspired the team with ambitious growth targets, was increasingly replaced by a stressed executive who struggled to balance investor expectations with operational realities. Board meetings that had once focused on market expansion opportunities now centered on customer retention risks and competitive threats from more established cloud providers. The financial implications of these technical problems became apparent through documents Maya encountered during her cleaning duties. Customer contract renewals were being delayed as clients demanded service-level agreement modifications and penalty clauses for future outages. Several enterprise prospects had postponed implementation decisions, citing concerns about Data Vault's ability to handle their scale requirements. The sales team's quarterly projections showed a significant shortfall from targets that had been set based on assumptions about continued technical stability. Sarah Kim found herself at the center of a technical crisis that was rapidly expanding. Beyond her team's ability to manage through conventional troubleshooting approaches, The distributed systems architecture that had worked adequately for Data Vault's initial growth phase was revealing fundamental limitations that couldn't be addressed through incremental improvements. The database sharding strategy was creating hotspots that overwhelmed individual servers during peak traffic periods. The load balancing algorithms were failing to adapt to the variable traffic patterns generated by enterprise clients with dramatically different usage profiles. The engineering team's response to these challenges followed a predictable pattern that Maya recognized from her experience at Amazon during similar crisis periods. Individual engineers worked increasingly long hours, implementing quick fixes and temporary workarounds that addressed immediate symptoms without resolving underlying architectural problems. The codebase accumulated technical debt as emergency. Patches were deployed without proper testing or documentation. System complexity increased exponentially as new monitoring tools and alerting systems were layered on top of existing infrastructure without coherent integration strategies. The technical solution wasn't simply adding more resources. It required implementing sophisticated queuing mechanisms that could prioritize and sequence large-scale operations to prevent resource contention. Maya had implemented similar solutions at Amazon Web Services when they faced comparable challenges during major promotional events that generated unprecedented traffic spikes. The approach involved creating dedicated resource pools for different types of operations and implementing intelligent scheduling algorithms that could coordinate multiple complex processes without overwhelming shared infrastructure components. But Maya's insights remained locked in her role as an invisible night shift worker, unable to contribute to the technical discussions that could resolve the crisis. She continued her cleaning duties while watching the engineering team pursue solutions that she knew would provide only temporary relief without addressing the fundamental architectural limitations that had enabled the systemic failure. The situation deteriorated further when the engineering team's attempts to restart individual database servers created additional instability in the distributed cluster. The restart operations interrupted ongoing data migration processes, causing partial data corruption that would require extensive recovery procedures even after the underlying connectivity issues were resolved. Morrison Financial's data integrity verification processes revealed inconsistencies that could invalidate their entire migration effort, potentially forcing them to restart the process from the beginning. By midnight, Data Vault was facing a complete service outage that affected not only the 3 enterprise clients attempting large-scale migrations, but also hundreds of smaller clients who depended on the platform for their normal business operations. The cascade failure had propagated through multiple system layers, creating a complex web of interdependent problems that couldn't be resolved through conventional troubleshooting approaches. Maya witnessed the moment when the engineering team realized that their conventional response procedures were inadequate for the scale and complexity of the crisis they were facing. Sarah Kim called an emergency all-hands meeting in the main conference room, bringing together engineers from all specializations to coordinate a comprehensive recovery strategy. But the team's diagnostic tools and monitoring systems weren't providing the visibility needed to understand how various system components were interacting during the failure scenario. The external pressure on Data Vault intensified dramatically as news of the outage spread through the technology industry. Social media posts from affected customers began attracting attention from technology journalists who specialized in covering cloud infrastructure failures. Industry analysts started questioning Data Vault's technical capabilities and competitive viability in the enterprise market. Stock market futures indicated that Data Vault's valuation would decline significantly when trading resumed the following morning. Marcus Thompson was fielding urgent calls from board members, investors, and enterprise clients who demanded explanations and resolution timelines that his technical team couldn't provide with confidence. The company's legal department was preparing for potential breach of contract lawsuits from enterprise clients whose business operations had been disrupted by the service outage. The customer success organization was overwhelmed by support tickets from clients seeking alternative solutions for their immediate data storage needs. The crisis reached its crescendo at approximately 1:30 a.m. when the engineering team's latest recovery attempt resulted in additional data corruption that affected backup systems designed to protect against exactly this type of catastrophic failure. The distributed backup infrastructure had been overwhelmed by the same resource contention issues that had caused the primary system failure, creating a scenario where both production and recovery systems were compromised simultaneously. Maya observed the mounting panic in the conference room as the engineering team realized that their standard disaster recovery procedures were insufficient for the current crisis. The backup systems that should have provided rapid restoration capabilities were experiencing the same architectural limitations that had caused the original failure. Recovery operations were competing for the same database resources that were needed for restoring normal service operations, creating a deadlock scenario where attempted solutions were actually prolonging the outage. Sarah Kim made the difficult decision to engage external emergency consulting services that specialized in large-scale infrastructure recovery, but these experts wouldn't be available until the following morning. The engineering team faced the prospect of continuing their troubleshooting efforts through the night without clear guidance on prioritizing their limited resources between immediate recovery and long-term stability improvements. The human cost of the crisis was evident throughout DataVault's offices as Maya continued her cleaning duties. Engineers who had been working for days with minimal sleep were making increasingly poor decisions under the pressure of constant escalation from management and clients. The collaborative culture that had once characterized DataVault's technical organization was being replaced by finger-pointing and defensive posturing as individual team members tried to avoid responsibility for the systemic failures. Maya found herself in the surreal position of being surrounded by brilliant engineers who were struggling with problems she could solve, but having no mechanism for contributing her expertise to the solution. She understood the specific configuration changes and architectural modifications that could restore service stability, but her role as a custodial worker made it impossible for her insights to reach the decision-makers who could authorize and implement the necessary changes. The crisis represented everything that was wrong with DataVault's approach to recognizing and utilizing human potential. The company had attracted talented engineers and provided them with substantial resources, but organizational hierarchies and assumptions about expertise prevented them from accessing the knowledge that could resolve their most critical challenges. Maya's experience with distributed systems architecture was exactly what they needed, but her current position made her invisible to the people who could benefit from her insights most. As the night progressed toward what would become the most consequential morning in DataVault's history, Maya continued her methodical cleaning routine while observing the unfolding crisis that would either destroy the company or create an opportunity for fundamental transformation. The stage was set for a collision between conventional thinking about technical expertise and the hidden potential that existed in the most unexpected places. At 2:47 a.m., when DataVault's crisis had reached its most desperate point, Maya made a decision that would change everything. She had been methodically emptying trash bins in the executive conference room, while the engineering team struggled with increasingly futile attempts to restore service stability. The latest recovery effort had failed catastrophically, actually. making the system instability worse by triggering additional cascade failures in components that had previously been functioning normally. Sarah Kim was on a conference call with emergency consulting services, but the external experts wouldn't arrive until 8 a.m., far too late to prevent the complete collapse of client relationships that were hanging by threads. Maya paused her cleaning routine and studied the architectural diagrams covering the conference room whiteboards. The visual representation of Data Vault's infrastructure revealed the fundamental design flaws that were preventing effective recovery. The system had been architected as a monolithic cluster rather than properly isolated service domains, which meant that failures in any component could propagate throughout the entire infrastructure. The database connection pooling was configured for normal operational loads rather than the specialized requirements of large-scale data migration operations. More critically, Maya could see that the engineering team was treating the crisis as a hardware capacity problem when it was actually a distributed systems coordination challenge. They were attempting to scale individual components rather than implementing the queue management and resource isolation strategies that could prevent different types of operations from interfering with each other. The solutions they were pursuing would provide temporary relief at best, but wouldn't address the architectural limitations that had enabled the systemic failure. Maya's journey to Data Vault's night shift began 3 years earlier with a phone call that shattered her world into irreparable fragments. She had been working late at Amazon Web Services, debugging a complex distributed caching issue that was affecting response times across their global infrastructure. The engineering war room buzzed with focused energy as her team methodically traced the problem through multiple service layers. Maya was in her element, her mind completely absorbed in the elegant challenge of untangling the interdependencies between dozens of microservices. Her phone rang at 11:47 p.m. The caller ID showed David's number, which was unusual since he knew she was working on a critical production issue. Maya almost let it go to voicemail, but something made her step away from her workstation and answer. The voice on the other end wasn't David's. It was a police officer from the California Highway Patrol, speaking in the careful, practiced tone that officers used when delivering life-altering news to unsuspecting families. David Chen had been driving home from his startup's office in Palo Alto when an intoxicated driver ran a red light at the intersection of Highway 35 and Page Mill Road. The impact had been instantaneous and fatal. David was pronounced dead at the scene before emergency responders could even attempt life-saving measures. The other driver, a 23-year-old Stanford student who had been celebrating his graduation, survived with minor injuries and would later plead guilty to vehicular manslaughter while under the influence. The immediate aftermath of that phone call existed in Maya's memory as a series of disconnected fragments. She remembered collapsing in the Amazon break room while her teammates looked on in shocked helplessness. She remembered the surreal experience of driving to the hospital to identify David's body, the fluorescent lights too bright, and the antiseptic smell overwhelming her senses. She remembered calling her parents in Seattle at 3 a.m., struggling to form coherent words as she tried to explain that their future son-in-law was gone. Maya and David had met during a weekend hackathon at Stanford. 3 years earlier, both were working on machine learning projects. David was developing algorithms for medical image analysis, while Maya was experimenting with neural networks for optimizing cloud resource allocation. They had ended up collaborating when Maya realized that David's pattern recognition techniques could be applied to predicting server load patterns. Their initial technical partnership had blossomed into late-night conversations about everything from philosophy to their shared dreams of using technology to solve meaningful problems. Their relationship had been built on intellectual partnership and mutual respect for each other's technical expertise. David specialized in machine learning and artificial intelligence, while Maya focused on large-scale distributed systems, but they complemented each other perfectly. David would help Maya understand the statistical foundations underlying various algorithms, while Maya would explain the practical constraints of implementing machine learning systems at scale. Their evening conversations often involved sketching architectural diagrams on restaurant napkins or debugging each other's code over weekend breakfast. They had purchased a modest 3-bedroom house in Fremont, choosing the location because it offered reasonable commute times to both of their jobs while providing space for the home office where they could work on side projects together. The house represented their shared vision of the future, a place where they could build both a family and a technology consultancy that would allow them to work on projects they were passionate about. The 3rd bedroom was designated as a nursery for children they planned to have within the next few years. David's startup, MedAnalytics, was developing artificial intelligence tools for radiologists to detect early-stage cancers in medical imaging. The company had recently secured Series TUT of funding and was preparing to launch their first commercial product. David was the lead algorithm architect, responsible for designing the machine learning models that could identify subtle patterns in X-rays and MRI scans that human physicians might miss. The work was technically challenging and personally meaningful. David's grandmother had died from lung cancer that was diagnosed too late for effective treatment. The night of the accident, David had been working late to prepare for a crucial demonstration to potential hospital clients. He had texted Maya earlier that evening, excited about a breakthrough in their image processing pipeline that would significantly improve diagnostic accuracy. He was planning to take a few days off after the demonstration so they could drive up to Mendocino for a long weekend they had been planning for months. Maya still had that final text message saved on her phone. "Can't wait to show you what we figured out today. This could change everything for early cancer detection." The grief that followed David's death was unlike anything Maya had experienced. She had lost grandparents and dealt with the normal sadnesses of life, but this was a complete disruption of her identity and future plans. Everything in their shared life reminded her of David, the coffee maker they had researched together for weeks before purchasing, the bookshelf filled with technical volumes they had discussed, the whiteboard in their home office covered with half-finished architectural diagrams from their last collaboration. Maya took emergency bereavement leave from Amazon, expecting to return after a few weeks once she had processed the initial shock and handled the practical details of death, funeral arrangements, insurance claims, legal paperwork. But as days turned into weeks, she found herself unable to concentrate on even simple tasks. Reading technical documentation triggered memories of explaining similar concepts to David. Working on distributed systems problems reminded her of their conversations about scaling machine learning infrastructure. The collaborative aspects of engineering work became particularly difficult because David had been her primary intellectual partner and sounding board. Amazon's human resources department was initially supportive and understanding. Her manager, Jennifer Walsh, had worked with Maya for 2 years and understood the depth of her technical contributions to the team. Jennifer offered flexible work arrangements, counseling resources, and extended leave options. But as Maya's absence stretched into months, the practical realities of maintaining a high-performance engineering team created pressure for resolution. Critical projects were being delayed, and Maya's specialized knowledge of certain systems was needed for upcoming product launches. After 4 months of medical leave, Maya realized she wasn't ready to return to the intense, collaborative environment of Amazon Web Services. The thought of debugging complex systems problems or leading architecture meetings triggered anxiety attacks that left her unable to breathe normally. She would sit in her car in the Amazon parking lot during scheduled Return dates, physically unable to walk into the building. The grief had fundamentally altered her relationship with work that had once been her primary source of identity and fulfillment. Maya's resignation letter was one of the most difficult documents she had ever written. She tried to explain her situation to Jennifer without going into details about her mental health struggles. She expressed gratitude for the opportunities Amazon had provided and apologized for leaving during such a critical project phase. Jennifer's response was compassionate but final. Amazon would welcome Maya back in the future if circumstances changed, but they couldn't hold her position indefinitely given the demands of their development schedule. The financial implications of leaving Amazon became apparent quickly. Maya and David had structured their finances around two substantial tech industry salaries, allowing them to maintain their mortgage, car payments, and lifestyle while saving aggressively for their planned future together. Without David's income, and with Maya no longer earning her Amazon salary, their carefully planned budget collapsed immediately. Maya's savings were primarily invested in technology stocks and retirement accounts that would incur significant penalties for early withdrawal. The life insurance payout from David's policy would eventually provide financial stability, but the claims process was complicated by the circumstances of his death and wouldn't be resolved for months. Meanwhile, mortgage payments, property taxes, and basic living expenses continued accumulating, regardless of Maya's emotional state or employment status. Maya's hands trembled slightly as she approached Sarah Kim, who was hunched over her laptop, coordinating with database administrators who were reporting conflicting information about cluster status and recovery progress. Maya had rehearsed this moment countless times in her mind, but actually interrupting a technical crisis meeting felt like crossing an invisible boundary that separated her world from the engineering community that was struggling with problems she understood intimately. "Excuse me," Maya said quietly, her voice barely audible over the urgent conversations happening throughout the conference room. Sarah looked up with obvious irritation, clearly expecting another interruption from someone who didn't understand the technical complexity of the situation they were facing. Maya's cleaning uniform and hesitant demeanor reinforced Sarah's assumption that this would be another distraction during a critical moment when every minute of delay could cost the company millions of dollars in lost revenue and client relationships. "I'm sorry to bother you during this crisis," Maya continued, her voice growing slightly stronger as she forced herself to speak clearly despite her nervousness. "But I think I might be able to help with the database coordination issues you're experiencing. I have experience with distributed systems architecture, and I can see some patterns in your monitoring data that suggest specific solutions." Sarah's initial response was a mixture of confusion and barely suppressed frustration. The suggestion that a custodial worker could contribute technical insights during a sophisticated infrastructure crisis seemed absurd on its face. But something in Maya's tone, the confident way she had used specific technical terminology like database coordination and distributed systems architecture, gave Sarah pause. These weren't phrases that someone without substantial technical background would use casually or correctly. "What kind of experience do you have with distributed systems?" Sarah asked, her skepticism evident but tempered by desperation. Data Vault's conventional approaches had failed completely, and external expert assistance was hours away. If there was any possibility that an unexpected source could provide useful insights, Sarah couldn't afford to dismiss it without investigation. Maya took a deep breath, knowing that her next words would either establish her credibility or confirm Sarah's assumption that she was an unqualified worker overstepping professional boundaries. "I spent 5 years as a senior software engineer at Amazon Web Services, specializing in elastic computing infrastructure and large-scale storage systems. I architected the load balancing solutions that handle traffic spikes during major promotional events, and I've dealt with exactly the kind of cascade failures you're experiencing tonight. The conference room fell silent as Maya's words registered. With the engineering team, Alex Rodriguez looked up from his monitoring displays with an expression of disbelief, while other team members stopped their urgent conversations to focus on this unexpected development. Sarah's skepticism transformed into intense curiosity as she processed the implications of Maya's claim. If true, Maya possessed exactly the expertise that Data Vault needed most urgently. "Can you be more specific about what you're observing in our system behavior?" Sarah asked, her tone shifting from dismissive to professionally interested. "What patterns are you seeing that we might be missing?" Maya moved closer to the whiteboard displaying Data Vault's architectural diagram, her confidence growing as she entered the familiar territory of technical analysis and problem-solving. "Your database cluster is experiencing resource contention because you're treating all operations as equivalent priority. The large-scale migrations are consuming connection pool resources that normal business operations need for basic functionality. You need to implement dedicated resource isolation for different operation types." She pointed to specific components in the architectural diagram as she continued her analysis. "The cascade failures are happening because your load-balancing algorithms don't account for the specialized resource requirements of data migration operations. When migration processes overwhelm individual database nodes, the load balancer redistributes traffic to other nodes, which then become overwhelmed in turn. You're creating a rolling failure pattern that will continue until you implement proper queue management." Alex Rodriguez pulled up real-time monitoring data on his laptop and compared it to Maya's analysis. The correlation between her observations and the actual system behavior was immediately apparent. The connection pool saturation she had identified was clearly visible in the database metrics, and the rolling failure pattern she described matched exactly what they had observed during the evening's crisis progression. "How would you recommend we address the immediate recovery challenges?" Sarah asked, now fully engaged in technical discussion with Maya. "We need to restore service for our normal business clients while completing the enterprise migrations that triggered this crisis." Maya studied the monitoring displays and architectural diagrams for several minutes, her mind automatically processing the complex interactions between various system components. Her approach to problem-solving reflected her experience with similar challenges at Amazon Web Services, where she had learned to think systematically about distributed systems failures and their solutions. "First, you need to implement emergency resource isolation," Maya explained, moving to the whiteboard to sketch modifications to the existing architecture. "Create dedicated database connection pools for migration operations so they can't interfere with normal business traffic. The migration processes should be queued and executed sequentially rather than concurrently to prevent resource competition." She drew additional diagrams showing how queue management systems could coordinate large-scale operations without overwhelming shared infrastructure. "Second, you need to modify your load balancing strategy to account for different operation types. Migration traffic should be routed to specific database nodes that are configured for high-throughput, long-duration operations. Normal business traffic should be isolated on nodes optimized for low-latency, high-frequency operations." Sarah was taking detailed notes as Maya continued her analysis, recognizing that these recommendations addressed fundamental architectural issues that her team had been struggling to understand. The solutions Maya proposed weren't just tactical fixes, but strategic improvements that would prevent similar failures in the future. "The immediate recovery requires careful sequencing," Maya continued, her voice now carrying the authority of someone who had managed similar crises successfully. You'll need to drain existing connections gracefully, implement the resource isolation changes, and then restart operations in a controlled manner. The enterprise migrations can be resumed once normal business operations are stable, but they should be executed one at a time with proper resource monitoring. Marcus Thompson, who had been managing external communications during the technical discussions, joined the group around the whiteboard as he recognized that a potential solution was emerging. He listened as Maya outlined specific implementation steps that could restore service stability while completing the critical enterprise migrations that were essential for DataVault's financial survival. How confident are you that this approach will resolve our current crisis? Marcus asked, recognizing that he was about to make a decision that could either save the company or accelerate its destruction. Implementing architectural changes during a live outage carried enormous risks, but continuing with failed conventional approaches guaranteed continued service degradation. Maya met Marcus's gaze directly, her nervousness replaced by the quiet confidence of someone who understood both the technical challenges and the business implications of various solutions. I've implemented similar architecture modifications during production outages at Amazon Web Services. The approach I'm recommending follows established patterns for managing resource contention in distributed systems. The risks are manageable if we execute the changes systematically. She pointed to specific components in her modified architectural diagram as she continued. The key is implementing changes incrementally so we can validate each step before proceeding. We can restore normal business operations first, then address the enterprise migrations once we've confirmed system stability. This approach minimizes risk while ensuring that we complete the client commitments that are essential for DataVault's survival. Sarah made the decisive recommendation that would transform DataVault's crisis into an opportunity for fundamental improvement. Marcus, I believe we should implement Maya's recommendations immediately. Her analysis is more comprehensive than anything our team has developed, and her proposed solutions address the root causes of our failures rather than just the symptoms. Marcus looked around the conference room at his exhausted engineering team, recognizing that conventional approaches had failed completely, while Maya's unexpected expertise offered the only viable path forward. The decision to entrust the company's technical recovery to someone who had been invisible to the organization just hours earlier represented a fundamental shift in how DataVault recognized and utilized human potential. Maya, Marcus said, his voice carrying the weight of a decision that would determine DataVault's future. I'm authorizing you to lead the technical recovery effort. Sarah, please provide Maya with whatever resources and authority she needs to implement these changes. Alex, I want your team to support Maya's implementation plan completely. The transformation in the conference room was immediate and dramatic. Maya, who had entered as an invisible custodial worker, was now directing the technical recovery of one of Silicon Valley's most promising cloud infrastructure companies. The engineering team that had been struggling with failed solutions was now implementing recommendations from someone whose expertise had been hidden in plain sight. Maya's first actions demonstrated the systematic approach she had learned during her years managing critical infrastructure at Amazon Web Services. She established clear communication protocols so that all team members understood their specific responsibilities during the recovery process. She implemented monitoring checkpoints that would allow them to validate each step before proceeding with subsequent changes. Most importantly, she created fallback procedures that would allow them to reverse changes quickly if unexpected problems emerged. The recovery process began with implementing emergency resource isolation that would prevent different types of operations from interfering with each other. Maya guided the database administrators through configuration changes that created dedicated connection pools for migration operations while preserving resources for normal business traffic. The implementation required careful coordination to avoid creating additional instability during the transition process. As the technical team executed Maya's recovery plan, the monitoring displays began showing immediate improvements in system stability and performance. Database connection timeouts decreased dramatically as resource contention was eliminated through proper isolation. Load balancing effectiveness improved as traffic was routed according to operation type rather than simple round-robin distribution. The cascade failures that had propagated throughout the system began resolving as individual components were no longer overwhelmed by inappropriate traffic types. Maya's leadership during the crisis revealed not only her technical expertise, but also her understanding of human dynamics during high-stress situations. She recognized that the engineering team's confidence had been shattered by hours of failed recovery attempts, so she made sure to explain the reasoning behind each recommendation and acknowledge the team's contributions to implementing the solutions. Her approach created collaborative problem-solving rather than hierarchical direction, allowing team members to understand and support the recovery process rather than simply following instructions. By 4:30 a.m., DataVault's normal business operations had been restored to full functionality, allowing hundreds of smaller clients to resume their essential data storage activities. The enterprise migrations remained paused, but Maya had established the architectural foundation needed to complete them successfully without risking additional system-wide failures. The immediate crisis had been resolved through solutions that also positioned DataVault for improved long-term stability and scalability. The successful resolution of DataVault's most serious technical crisis marked the beginning of Maya's transformation from invisible custodial worker to recognized technical leader. But more importantly, it demonstrated the hidden potential that existed throughout organizations when barriers to recognition and contribution were removed. Maya's expertise had been present all along, waiting for circumstances that would allow it to be acknowledged and utilized effectively. The immediate aftermath of Maya's successful crisis intervention sent shockwaves through DataVault technologies that extended far beyond the technical recovery. By 6 a.m., when the engineering team had completed the systematic restoration of all enterprise migration operations, word of the unprecedented turnaround had spread throughout the company. Employees arriving for the early morning shift found a transformed organization where assumptions about expertise, hierarchy, and potential had been fundamentally challenged by the events of the previous night. Marcus Thompson called an emergency all-hands meeting at 9 a.m. to address the company-wide implications of the crisis and recovery. The main auditorium filled with employees who had heard conflicting rumors about the previous night's events. Some claiming that an external consultant had saved the company, others suggesting that a breakthrough in the engineering team's efforts had finally resolved the technical problems. The truth was more extraordinary than any of the speculative explanations circulating through the office. Marcus began the meeting by acknowledging the severity of the crisis that had threatened DataVault's survival. He explained how the simultaneous enterprise migrations had exposed fundamental architectural limitations that conventional troubleshooting approaches couldn't resolve. He described the mounting pressure from clients, investors, and board members who had questioned whether DataVault possessed the technical capabilities necessary to compete in the enterprise cloud storage market. Then, Marcus introduced Maya to the stunned audience, explaining that the night shift custodial worker possessed the distributed systems expertise that had enabled DataVault's recovery. The revelation that someone they had all walked past countless times without acknowledgement was actually a former Amazon Web Services senior engineer created a profound moment of collective recognition about hidden potential and organizational blind spots. Maya found herself standing before hundreds of colleagues who had never truly seen her before, despite her physical presence in their workplace for months. She wore the same cleaning uniform that had marked her as invisible during her custodial duties, but now it served as a powerful symbol of how superficial indicators could obscure genuine capability and contribution. Her voice was steady as she addressed the audience, though she could feel the weight of their attention and the significance of this unprecedented moment. 6 months ago, I was designing infrastructure for systems that serve millions of users, Maya began, her words carrying the quiet authority she had demonstrated during the crisis recovery. Last night, I was emptying trash bins while watching brilliant engineers struggle with problems I could solve. The gap between those two realities isn't about technical ability, it's about recognition, opportunity, and our assumptions about where expertise can be found. Maya's presentation to the company focused not on her individual transformation, but on the broader implications for how organizations identify and develop human potential. She described observing the engineering team's challenges during her cleaning duties, recognizing problems that matched her previous experience at Amazon Web Services, but having no mechanism for contributing insights that could prevent costly mistakes and delays. Data Vault employs incredibly talented people, Maya continued, scanning the audience that included many of the engineers she had worked with during the night's recovery. But talent without recognition is potential without impact. How many other insights are we missing because we're not listening to voices that don't fit our expectations about expertise? How many solutions remain hidden because we've created systems that only recognize certain types of contribution? The employee response to Maya's story was immediate and emotional. Many staff members recognized themselves in her experience of feeling invisible or undervalued, despite having valuable contributions to offer. Others acknowledged that they had participated in organizational blind spots that prevented recognition of unconventional expertise. The meeting became a catalyst for broader discussions about inclusive leadership and the systems that either amplify or silence different voices within organizations. Sarah Kim spoke next, providing technical details about how Maya's architectural recommendations had resolved the crisis, while also establishing foundations for improved long-term scalability. She explained that Maya's solutions weren't just emergency fixes, but strategic improvements that positioned Data Vault to handle much larger enterprise clients without experiencing similar failures. The technical approach Maya had recommended followed best practices for distributed systems design that Data Vault's team was still learning to implement effectively. Maya's intervention saved our company, Sarah said, her words carrying the weight of someone who understood how close Data Vault had come to complete collapse. But more importantly, her expertise represents the kind of architectural thinking we need to build systems that can scale reliably as we grow. I'm recommending that Maya be promoted immediately to Senior Infrastructure Architect, with responsibility for guiding our technical strategy and mentoring our engineering teams. Marcus announced Maya's promotion with an authority that reflected both recognition of her demonstrated capabilities and acknowledgement of Data Vault's organizational transformation. The position came with a salary that exceeded her previous Amazon compensation, equity participation that would make her a stakeholder in Data Vault's future success, and most importantly, the authority to implement the architectural changes needed for sustainable growth. But Maya's promotion was accompanied by broader systemic changes that addressed the organizational blind spots that had kept her expertise hidden. Marcus announced the creation of a Hidden Talents initiative that would actively seek insights and contributions from employees at all levels of the organization. The program would include regular forums where any staff member could propose solutions to technical or business challenges, regardless of their official role or traditional qualifications. The initiative also established mentorship programs that paired experienced professionals with employees who showed potential for growth beyond their current positions. Roberto Martinez, the security guard who had always treated Maya with respect and recognition, was invited to participate as both a mentor and mentee, sharing his insights about building security while learning about career development opportunities. Within the technology industry, DataVault's client relationships were transformed by the successful resolution of the crisis and the story behind the recovery. Morrison Financial, TechFlow Manufacturing, and Meridian Healthcare not only completed their migration successfully, but became advocates for DataVault's approach to recognizing and developing human potential. The enterprise clients appreciated working with a company that demonstrated both technical competence and commitment to inclusive leadership practices. Dr. Patricia Williams, TechFlow Manufacturing's CTO, became particularly interested in Maya's background and the organizational transformation her recognition had sparked. The fact that DataVault was able to identify and promote talent from within their own organization during a crisis demonstrates exactly the kind of adaptive leadership we want in our technology partners, she explained during a client testimonial that DataVault would later use in their marketing materials. The technology industry response to Maya's story was equally significant. Technology publications featured DataVault as an example of how companies could unlock hidden potential and build more innovative organizations. Industry conferences invited Maya to speak about her experience and the lessons it offered for inclusive leadership in technical environments. Her presentations consistently emphasized that her individual success was less important than the systemic changes needed to recognize and develop potential wherever it exists. Maya's new role as senior infrastructure architect allowed her to implement the comprehensive architectural improvements that DataVault needed for sustainable scalability. She led the design of distributed systems that could handle traffic loads 10 times larger than their previous capacity, while maintaining the reliability standards demanded by enterprise clients. Her architectural approach reflected both her technical expertise and her understanding of human factors in system design and operation. The engineering culture at DataVault evolved dramatically under Maya's technical leadership. She established code review practices that emphasized knowledge transfer and mentorship rather than simply identifying defects. She implemented documentation standards that captured not just technical specifications, but also the reasoning behind architectural decisions, ensuring that institutional knowledge would be preserved as the team continued growing. Maya's leadership style reflected her own experience of being overlooked and undervalued. She created regular opportunities for junior engineers to propose innovative solutions and present their ideas to senior leadership. She established architecture office hours, where any team member could discuss technical challenges or career development goals directly with her. Most importantly, she actively sought diverse perspectives on technical decisions, recognizing that the best solutions often emerged from collaborative problem-solving rather than individual expertise. The financial impact of Maya's contributions extended far beyond the immediate crisis resolution. DataVault's improved technical architecture enabled them to pursue larger enterprise contracts that had previously been beyond their capabilities. Client retention rates improved dramatically as system reliability reached levels that exceeded competitor offerings. The company's valuation increased substantially as investors recognized both the technical improvements and the organizational innovations that had produced them. Maya's personal transformation was equally profound. She enrolled in Stanford's part-time MBA program to complement her technical expertise with formal business education. She became a sought-after advisor for other technology companies, facing similar challenges with organizational inclusion and talent development. Her speaking engagements at industry conferences helped establish her as a thought leader in both distributed systems architecture and inclusive leadership practices. But Maya remained grounded in the fundamental insight that had driven her transformation. The recognition that potential exists in unexpected places and that organizations succeed by creating systems that amplify diverse voices rather than reinforcing conventional hierarchies. She continued mentoring other employees who felt undervalued or overlooked, helping them develop strategies for contributing their expertise effectively within existing organizational structures. The broader technology industry began studying Data Vault's transformation as a model for inclusive innovation and talent development. Harvard Business School developed a case study about Maya's story that was used in leadership development programs throughout Silicon Valley. Other companies implemented similar hidden talents initiatives, recognizing that their competitive advantage might depend on identifying and developing potential that conventional hiring and promotion practices overlooked. Maya's story became a powerful example of how individual transformation could catalyze systemic change when organizations were willing to challenge their assumptions about expertise and contribution. Her journey from invisible custodial worker to senior technical leader demonstrated that talent recognition was often a matter of creating opportunities for contribution rather than identifying inherent capabilities through traditional assessment methods. Roberto Martinez, the security guard who had always seen Maya's potential, was promoted to facilities operations manager with responsibility for developing career pathways for all support staff throughout Data Vault's organization. His new role reflected the company's commitment to recognizing potential wherever it existed and creating advancement opportunities that weren't limited by traditional educational or professional backgrounds. The cultural transformation at Data Vault extended to hiring practices that prioritize diverse perspectives and unconventional backgrounds alongside traditional qualifications. The company began recruiting from community colleges, coding boot camps, and career transition programs, recognizing that technical expertise could be developed through multiple pathways beyond conventional computer science education. Maya's architectural improvements to Data Vault's infrastructure became the foundation for sustained growth that positioned the company as a legitimate competitor to established cloud providers. The systems she designed could scale to support millions of users while maintaining the reliability and performance standards that enterprise clients demanded. More importantly, the architectural approach she established could be understood and maintained by the growing engineering team, ensuring that Data Vault's technical capabilities would continue evolving effectively. The success of Data Vault's transformation attracted attention from venture capital firms and potential acquisition targets who recognized both the technical improvements and the organizational innovations that had produced them. But Marcus Thompson and the board of directors chose to maintain Data Vault's independence, believing that their approach to inclusive leadership and talent development would continue generating competitive advantages that justified continued growth rather than acquisition. Maya's story continued inspiring individuals and organizations throughout the technology industry and beyond. Her experience demonstrated that transformation was possible when courage combined with opportunity, when organizations were willing to challenge their assumptions about potential, and when leaders recognized that the best solutions often came from unexpected sources. Her journey from invisible custodial worker to senior infrastructure architect had become a powerful example of human potential and organizational possibility that resonated far beyond the specific circumstances of DataVault's crisis and recovery. 2. Years after that transformative February night, Maya stood before a packed auditorium at the annual Tech Inclusion Conference in San Francisco, delivering the keynote address to over 3,000 technology leaders, engineers, and entrepreneurs. The venue was symbolic, the same convention center where she had once attended job fairs as an unemployed engineer, desperately hoping someone would look past her resume gap and recognize her potential. Now she was the featured speaker, but more importantly, she represented a fundamental shift in how the technology industry thought about talent, potential, and organizational transformation. DataVault Technologies had become one of Silicon Valley's most celebrated success stories, not just for their technical achievements, but for their revolutionary approach to inclusive leadership. The company now employed over 800 people and served enterprise clients across 6 continents. Their distributed systems architecture, originally designed during Maya's crisis intervention, had become the gold standard for cloud storage reliability. But the metrics that Maya was most proud of weren't financial, they were human. When I tell people about my journey from night shift custodian to senior infrastructure architect, they often focus on the dramatic transformation, Maya said, her voice carrying easily through the large auditorium. But the real story isn't about one person's change in circumstances. It's about what becomes possible when organizations commit to seeing potential wherever it exists and creating systems that amplify voices, regardless of where they come from. The audience included CEOs from major technology companies, venture capital partners who funded Silicon Valley's growth, and engineers at all career stages who were hungry for examples of how inclusive practices could drive innovation. Many were taking detailed notes, recognizing that Maya's insights could transform their own organizations in fundamental ways. Maya's presentation included compelling data about DataVault's transformation. Employee retention had improved by 150%, as workers felt more valued and recognized for their contributions. Innovation metrics showed that the best solutions increasingly came from collaborative efforts that included perspectives from multiple organizational levels. Customer satisfaction had reached industry-leading levels as the company's inclusive culture translated into better understanding of diverse client needs. We discovered that talent development isn't about identifying the smartest people in the room, Maya continued. It's about creating environments where everyone's intelligence can contribute to solving problems. Some of our best architectural insights have come from customer service representatives who understand user pain points, facilities managers who notice infrastructure patterns, and yes, custodial workers who observe system behaviors that engineers. Miss Roberto Martinez, now DataVault's Director of Operational Excellence, was in the audience wearing a suit that reflected his transformation from security guard to senior manager. His department had become a model for career development programs that helped employees transition between roles based on demonstrated capabilities rather than traditional qualifications. Under his leadership, DataVault had achieved the lowest turnover rate in Silicon Valley while maintaining the highest employee satisfaction scores in the technology industry. Maya's presentation included case studies from other companies that had implemented similar inclusive leadership practices. A biotechnology firm in Boston had discovered breakthrough research insights from laboratory technicians who had observed experimental patterns that PhD researchers had missed. A financial services company in New York had prevented a major security breach because a facilities manager had noticed unusual network activity during routine maintenance rounds. An aerospace manufacturer in Seattle had solved critical engineering challenges by incorporating feedback from assembly line workers who understood practical implementation constraints that design engineers hadn't considered. The traditional model assumes that expertise flows downward through organizational hierarchies, Meyer explained. But innovation actually emerges from the intersection of different perspectives and experiences. The most valuable insights often come from people who see systems from angles that conventional expertise doesn't consider. Sarah Kim, now DataVault's Chief Technology Officer and Meyer's closest collaborator, had implemented technical mentorship programs that paired senior engineers with employees from non-technical backgrounds who showed interest in developing programming skills. Several customer service representatives had transitioned into software development roles, bringing user perspective that improved product design significantly. The facilities management team had contributed insights about energy efficiency that reduced DataVault's operational costs by millions of dollars annually. Meyer's story had attracted international attention, leading to speaking engagements across Europe, Asia, and South America. She had consulted with governments about inclusive innovation policies and worked with educational institutions to develop curricula that prepared students for collaborative problem-solving rather than competitive, individual achievement. Her approach emphasized that the future of technology would depend on organizations' ability to harness collective intelligence rather than rely on heroic individual contributors. The DataVault Hidden Talents Initiative had expanded beyond identifying internal potential to actively recruiting from unconventional backgrounds. The company partnered with community colleges, veterans organizations, and career transition programs to identify candidates who possessed valuable skills that traditional hiring processes might overlook. Their engineering team now included former teachers who understood learning systems, military veterans who brought operational discipline, and career changers who offered fresh perspectives on technical challenges. Marcus Thompson had leveraged DataVault's transformation into a broader platform for promoting inclusive leadership throughout Silicon Valley. He served on advisory boards for multiple diversity and inclusion organizations, shared best practices with other CEOs, and invested personally in startups founded by entrepreneurs from underrepresented backgrounds. His leadership style had evolved to prioritize creating opportunities for others rather than commanding attention for himself. The most important lesson from DataVault's transformation, Meyer said as her presentation reached its conclusion, is that potential is universal, but opportunity is not. Every organization contains untapped wisdom, creative solutions, and innovative perspectives. The question isn't whether this potential exists, it's whether we're willing to create systems that recognize and develop it. Meyer's personal life had been transformed along with her professional circumstances. She had completed her MBA at Stanford while working full-time, focusing her thesis research on organizational behavior and inclusive leadership practices. She had purchased a home in Palo Alto, creating space for the family she hoped to build. In the future, most importantly, she had developed a sense of purpose that extended beyond her individual success to encompass systemic change that could benefit others facing similar challenges. The technology industry had begun measuring success differently as Meyer's story influenced broader conversations about value creation and human potential. Companies were implementing potential audits that identified overlooked capabilities within their existing workforce. Investment firms were evaluating startups based on their inclusive leadership practices alongside traditional financial metrics. Industry publications were featuring stories about transformation and recognition rather than just technological breakthroughs and funding announcements. Maya's keynote address concluded with a challenge to the audience that reflected her understanding of leadership as service rather than status. I want each of you to identify someone in your organization whose potential you haven't fully recognized. Find the person who sees patterns others miss, who asks questions that reveal assumptions, who solves problems quietly without seeking credit. Create an opportunity for their voice to be heard and their insights to contribute to important decisions. The response was immediate and sustained applause that reflected both appreciation for Maya's presentation and commitment to implementing her recommendations. During the networking reception that followed, dozens of technology leaders approached Maya with stories about overlooked employees in their own organizations and plans for creating more inclusive recognition systems. DataVault's success had demonstrated that inclusive practices weren't just morally important, but competitively advantageous. Companies that recognized and developed diverse talent were consistently outperforming organizations that relied on traditional hiring and promotion approaches. The business case for inclusion had been established through measurable results that influenced industry practices throughout Silicon Valley and beyond. Maya's story continued inspiring individuals who felt undervalued or overlooked in their own careers. She received hundreds of emails from people who had been motivated by her example to speak up about solutions they could contribute or challenges they could address. Many described finding courage to share insights they had previously kept to themselves, leading to recognition and advancement opportunities they hadn't thought possible. The broader implications of Maya's transformation extended beyond the technology industry to influence discussions about potential and recognition in education, healthcare, manufacturing, and public service. Her story had become a powerful example of how individual transformation could catalyze systemic change when organizations were willing to challenge their assumptions about expertise and contribution. As Maya left the conference center that evening, she reflected on the journey that had brought her from invisible custodial worker to recognized thought leader. The path had been unexpected and often difficult, but it had led to insights about human potential and organizational transformation that could benefit countless others facing similar challenges. Her story was no longer just about personal success, but about the systemic changes needed to create organizations where everyone's potential could be recognized and developed. If Maya's story resonates with you, it's likely because you've experienced moments of feeling invisible, having insights that weren't heard, or recognizing potential in others that wasn't being acknowledged. Perhaps you've been in Maya's position, possessing expertise that wasn't recognized because of assumptions about where knowledge comes from. Or maybe you've been like Marcus and Sarah, learning to see and value different types of contribution and intelligence. Maya's transformation reminds us that in every workplace, every organization, every community, there are people whose potential remains hidden beneath surface assumptions about capability and worth. The quiet observer who notices patterns others miss. The support staff member who understands systems from unique perspectives. The career changer who brings fresh insights to established problems. These voices aren't just waiting for permission to contribute. They're waiting for recognition that their perspectives have value. The next time you encounter someone whose role doesn't traditionally include strategic input, consider whether they might possess insights that could transform your understanding of important challenges. Create opportunities for different voices to contribute to problem solving. Challenge organizational systems that only recognize certain types of expertise. Remember that innovation often emerges from unexpected intersections of knowledge and experience. Maya's story proves that transformation is possible when courage meets opportunity, when organizations prioritize potential over credentials, and when leaders recognize that the best solutions often come from the most unexpected sources. Every person contains multitudes of capability and insight. The question isn't whether potential exists, it's whether we're willing to create systems that allow it to flourish. Subscribe to our channel for more stories about human potential, organizational transformation, and the hidden capabilities that exist in every workplace. Share this video with someone who needs to hear that their insights matter, their perspective has value, and their potential deserves recognition. Because in a world that often rewards the loudest voices, sometimes the most important thing we can do is create space for the wisdom that speaks quietly but carries profound truth.